Lesson 7-1, Multiplying Monomials. Our essential question today is how do you determine if an expression is a monomial? Our first vocab word is a constant. A constant is just a number because a constant means to stay the same. So, for example, the number 5 would be a constant because unlike a variable, the number 5 is just 5. Or maybe it's a negative number like -7, or even a fraction or a decimal. So a constant is just a number. A monomial, I'm going to explain what a monomial is by giving you some examples. 5 is a monomial because a monomial is one term. Another monomial could be -4x. -4x is a monomial because it's just one term. Or maybe 3/4 x squared y to the third. That's also a monomial. So a monomial is a product of, it could be a product of a constant and a variable, or maybe a constant and more than one variable. The variables could have exponents on them because that represents a product of variables, or they could just be a constant number. So a monomial means one term. The prefix mono means one, so one term that could contain a constant and or a product of variables. So hopefully that makes sense. So it's one term that could contain a constant and or a product of variables and a constant. So it can have a plain number, it can have a plain letter, or any combination that would be a product of numbers and letters. Product of numbers and letters. So maybe there's a better way to say that. So let's say one term that could contain a number, a variable, or a product of numbers and variables. Okay, so that takes us right into the next vocab word that says product of powers. A product of powers, product means to multiply, and powers are exponents. So a product of powers, an example is like x to the power of a times x to the power of b equals x to the power of a plus b. So that's an example of the product of powers. So product is multiplying. And powers are terms with exponents on them. And you'll see in our next examples why that product of powers works, why it makes sense. Okay, so identify the monomials. So we said it was a product of, like multiplied together, it was a product of constant and one or more variables. So I'm going to say this is just a constant, so that's a monomial. This is a constant, so it's a monomial, one term. This one is a monomial because it's a product of a number and two different letters. This one is a monomial, product of a constant and 4 different letters. And this one, product of a constant and 3 different letters. Now these other ones, this isn't a monomial because you can't divide by a variable. So this one's not a monomial either. Remember we talked about polynomials? Polynomials, you couldn't have a variable on the bottom. You couldn't have a negative exponent. And then these two are actually binomials because they've got two separate terms separated by the plus. Now, simplify the expression. These expressions are products of powers, b to the second power is b times b. That's what b to the second power means. The exponent means that you repeat that multiplication. B to the fifth power means that I would have 5 b's multiplied together. So now, if you take a look at what we're working with, we've now got how many letter b's multiplied together? 7 of them. So, b to the second power times b to the fifth power, if we expand it out, you can see visually that that would equal b to the seventh power. B to the seventh power. The next one, g to the fourth power, so that would be 4 g's multiplied together, times g to the sixth power, so 6 g's multiplied together. So hopefully you're kind of getting the hang of this by expanding. So now, how many g's do I have in all? 10. So g to the 10th power. So the shortcut is that if these base variables are the exact same, you can add together their exponents in the product of powers. So x to the first times x to the second times x to the seventh. I could add together these exponents and I get x to the 10th power. So you can expand it, or you can remember that that rule says that when the base is the same, the product of powers means you would add. This next one, I'm going to expand -6 times n to the third, and then I've got times 2 times n to the seventh, okay? So now I'm going to do something a little different on this one. I'm going to take these two numbers and I'm going to regroup them. -6 times 2 is -12. Now I can combine my n's, and I've got 3 of them and 7 of them, so I have 10 n's altogether. So my answer in simplified form should be -12 n to the 10th power. So the coefficient numbers, -6 times 2 is -12. You do not add at all with these coefficients, you multiply them. You multiply them. So -6 times 2 is -12, and then you can see that 3 plus 7 is 10, and that is what we have for a solution. This next one, 3 times p times t to the third power would look like this. P to the third power times t to the third power would look like this. So I only have one coefficient, number 3. I have, if I count how many p's I have, 1, 2, 3, 4 p's. So p to the fourth power, and then t, 1, 2, 3, 4, 5, 6. So t to the sixth power. That is simplified. Again, up at the top, if I put a 1 here, I can add together the exponents on my letter p to get 4, and then I can add together my exponents on the letter t to get 6. So the variables have to be the same for you to be able to use the product of powers to add together their exponents. The coefficient numbers, you are not adding at all. One more example, getting a little more complicated here. Expanding the first one. expanding the second one. And expanding the last one. Notice that on this last one, with the negative sign, that means the coefficient is -1. So now, if I multiply together my coefficients, I will get 21, positive 21. Then I can count how many x's I have. 1, 2, 3, 4, 5, 6, 7, 8. I have x to the 8th power, and then y's 1, 2, 3, 4, 5, 6, 7, 8. So y to the 8th power. Simplified form. So this x would have a 1 on it. So if I added all of these x's together, 1 plus 5 plus 2, I have 8 x's in all. And if I add these y's together, there would be 1 right here. So 4 plus 1 plus 3, 8 in all. And I had to multiply together all of my coefficient numbers to get the 21. You should be able to write a summary now. And here are your homework problems for day 1.